What's happening, guys? So today we're going to do a very quick revision summary and then hit some questions all around powers and logarithms. So let's start off with our revision summary. So let's take a look at the rules of powers. So if you've got a to the power of m times by a to the power of n, so that's going to be the same as a to the power of m plus n. And then same thing for division is going to be m minus n, and then you've got m a to the power of m all to the power of n is m times n, and then our important results, so a to the power of 0 equals 1, a to the power of minus m equals 1 over a to the m. So just remember, to get rid of that negative, you just you just take the reciprocal, and remember to it works the other way as well. If you want to get rid of the fraction, just change the sign of the power. And then a to the 1 over m is the nth root of a, and then finally a to the power of n divided by m can either be it can either be a to the power of n and then the nth root of that, or take the nth root of a and then take the power of n. So that's the same. The order in which you run it does not matter. And then revision summary for rules of logs. So log of x y equals log of x plus log of y. Log of x divided by y is log of x minus log of y. And then log of x to the power of n, this n just goes on the left side of the log, so you're left with n times the log of x. And then just some important results. You've got log of 1 equals 0, with the base a of a equals 1, log with the base a to the x is just equals x, and then a to the power of log with the base a, x equals x, and then finally log with the base a of b equals 1 over log with the base b of a. So just remember the bases change when you do this. So let's take a look at some examples. So in order to solve this, what we need to do is break each term individually, reduce those down, and then we can combine them later. So let's start off with, well, let's start off with that one. So we have 4a cubed b to the power of minus 1 c all squared. Okay, that's going to leave you with 16a cubed times 2 b to the minus 1 times 2 c 1 times 2. Okay, and that's going to be 16a to the power of 6 b to the power of minus 2 c to the power of 2. So we can write this first bit as 16a to the power of 6 b to the minus 2 c to the 2. Okay, now let's look at this one, shall we? So we've got a to the power of minus 2, b to the 4, c to the minus 2, all to the power of a half. And that's going to be a to the minus 2 times a half, b to the 4 times a half, c to the minus 2 times a half. And that's going to leave you with a to the minus 1, b squared, c to the minus 1. Okay, so we'll say that times a to the minus 1, b squared, c to the minus 1. And this last one is going to be 64 a to the power of 6 b to the power of 4 c squared to the power of minus half. Now first note that this power of a half is everything inside the brackets and not the 64. So we're left with 64. Well, yeah, that's the first thing. And then the second thing is what we want to do is we want to get rid of this minus. And just to remind you, to get rid of the minus, we just do 1 over and we're left, with a to the power of 6, b to the power of 4, c squared, all to the half. So that's going to leave you with 64 over a to the 6 times a half, b to the 4 times a half, c to the 2 times a half. Okay, and then that's going to be 64 over a to the 3, b squared, c. Okay, so that's going to be divided by 64 over a3, b2, c1. And now let's just combine this together. We're looking at 16a a to the 6, b minus 2, c to a to the minus 1, b to c minus 1, divided by 64. Remember, this is a division, times by the denominator. So we've taken the reciprocal of this. And let's collect the like terms just to simplify this. So we're going to be left with 16 over 64 times a to the 6, b minus 1, a cubed, b minus 2, b squared, and then c squared, c minus 1, c. Okay, and right, so let's just do, that's going to be 1 over 4. 6 minus 1 is 5 plus 3 is 8. You've got b, well these two cancel, so we're left with b squared, and then you've got c squared. Right, so and that should be the solution to this question. Let's move on. So another complicated example. Right, so we're going to do exactly the same thing. Now we're going to do exactly the same thing. Let's start off with this. So you've got the cube root of 8a cubed b to the 6 can be written as 8a cubed b to the 6 over 1 over 3, and that equals 8 to the power 1 over 3, a 3 times 1 over 3, b 6 times 1 over 3. So that's going to be 2ab squared. Okay, 3 times a third is 1, and 6 times a third is 2. Alright, so we'll say that that equals 2ab squared. Now let's take a look at 1 over 25, a to the 4, b to the 7. So that's going to be 1 over 25, a to the 4, b to the 7 to the power of a half equals 1 to the half, 25 to the half, a to, just make sure it's clear that this is the numerator, 4 times a half, b to the 7 times a half. And that's going to leave you with 1 over 5, a squared, b 7 over 2. Squared 7 over 2. Okay, so that's a divide 1 over 5 a squared b 7 over 2. And then this last one we'll say is 16 root a 4b. Well, let's not do that. Let's first, we need to get rid of this third here. So we're going to say square root of a to the 4b to the 6 equals a to the 4b to the 6 to the half equals, I'm going to rewrite this out. I'm just going to say 4 times a half is squared, 6 times a half is 3. Okay, so if we look at 16a squared b 3 to the power of minus a half, that leaves you with, remember it's to the power of everything inside this. That's 1 over 16a squared b cubed to the half, and that's going to be 1 over 4a, 2 times a half is 1, and b 3 times a half is 3 over 2. So that times 1 over 4a b 3 over 2. So let's combine this. We're going to be left with 2ab squared up here divided by this. Well, divided by 1 over 5 is the same as times by 5. And then this bit down here, b squared 7 over 2. And then times by this. So that's going to be times 4ab over 3 over 2. Right, so we can simplify this down. So let's take the coefficients. So you've got 2 times 5 divided by 4. So that's going to be 10 over 4 or 5 over 2. And then we're left with a squared, ab squared. This a and this a is a to the 3. This b and this b is going to be 3 over 2. It's going to be b to the 10 over 2, which is the same as b to the 5. And so this can simplify it down to, well, that knocks off that knocks off 2 here, that knocks off 1 here, and we're left with 5 over 2a squared b cubed. Okay, that should be the solution to it. And then just some logarithmic examples. Right, so express the following without logs. Now, in order to remove the logs, we need to first get rid of each of these terms and combine them. So we're going to use our rules of logs to say that log of a k equals, well, remember, log of p minus log of t is the same as log of p divided by t, and then log of t plus, well, let's just take a look at that one. That's the same as writing log of v to the power 1.3. And to get rid of that plus, what we're going to have to do is times by 1, v to the power 1, 3. Okay, so to get rid of the logs here, we just take the inverse logs on both sides, and what we're left with is k equals p v to the power of 1.3 over t. And then final example, so write this in log form. What we're going to do is take the logs on both sides. So let's just say log r equals log r f plus p f minus p. And then what we'll note is this can be split up using the product of logs. So we will have log r plus log root f plus p over f minus p. And then we can rewrite that one as log of f plus p over f minus p all to the power of a half, which we know is 1/2 log f plus p f minus p. So let's rewrite this. We've got log r equals log of r plus a half log f plus p f minus p. And so finally we can just say log of r equals log of small r plus half log of, so we're going to split this up by saying that that's going to be log of f plus p minus log of f minus p, and we're done. Alright, so hopefully those questions were helpful, and yeah, I will see you on the next one. Thank you for watching.